Hi guys, welcome to Science Chomp. Today we're going to be looking at specific heat capacity part 2. Now in this situation we're going to take this basic knowledge and we're going to combine it with something called a calorimeter, which looks a little bit like this. So here we've got an electric heater, a cup and some water in it, and the temperature goes up. So look specifically at that question, but we've got to combine it now with energy, power and time. So energy is power times time, and the idea is you're putting an electric heater in this cup and it's warming up the water, and well, let's just read the question and take it from there. So the figure below shows a plastic cup. The cup contains sand, an electric heater and a thermometer. Okay, my bad, it's sand and not water in this case. Okay, fair enough. The power of the heater is 50 watts. The mass of the sand in the cup is 550 grams. The initial temperature of the sand is 20 degrees Celsius. The heater is switched on for 2 minutes. The temperature is recorded until the temperature stops increasing. The highest temperature recorded by the thermometer is 33 degrees Celsius. Calculate the energy supplied by the heater. And then we'll get on to the other bits. So that's quite an interesting, fairly tricky question. So let's tackle this. So first of all, let's write down everything that we know. So the power, by the way, power is measured in watts. So this is 50 watts. The mass is 550 grams. Now, what you've got to do is you convert that into kilograms by dividing by 1,000. So divided by 1,000, and that gives you 0.55 kg, so that's the mass. Initial temperature, so let's call that Ti, is 20 degrees Celsius. Tf is 33, that goes all the way to 33 degrees Celsius. And so that change is 13, so delta T equals 13 degrees Celsius. Great. And the heater is switched on for 2 minutes. So time equals 2 minutes. However, we can't actually use minutes for this one. We have to use seconds. So that is 2 times 60 is 120 seconds. The reason being, 1 watt is 1 joule per second. So you've got to measure it in seconds. Okay, what are we trying to work out here? The energy supplied by the heater. All right, well, that's easy enough. So energy is power times time. The power is 50. The time is 120. So that would be 6,000 joules. So part 1 was pretty easy. Let's have a look at part 2. So calculate the value of the specific heat capacity of the sand. All right, great. Let's try that. Okay, so specific heat capacity is C, and C is Q divided by M delta T, right? So the Q is going to be the same as the energy. If you look back, the energy is 6,000 joules, so that's how much was transferred into the sand by the heater. So that's going to be the same as over here. So 6,000 divided by the mass of the sand, which is 0.55, multiplied by the delta T, which is 13 degrees Celsius. Do that, and that is 42,900 joules per kilogram degree C. Nice and easy. Let's now look at the very last part of the question. Explain why the specific heat capacity of sand may be different from the value calculated. Well, it could be different from this because when you have a situation like this, what's going to happen is you can have heat escaping through the top over there. So as a result, you don't never get like 100% efficiency. And so it could just completely affect the results. Thank you very much, and I'll see you in the next part.